This is a tutorial, so the expectation at a certain point will be that I'll stop talking quite so much and you guys will start coding. So we're going to go through some conceptual slides, but the slideshow itself is fairly short compared to everything that we're going to do. If you came here because you were excited about the Pygame in the title, the Pygame is going to be a fairly small portion of what we're doing. We're focusing mostly on the architecture that will allow you to write programs that will grow a little bit more gracefully than maybe what you've written before. Okay, so some of the tools that I'm going to use, if you don't already have these, you can download while we're talking. I'm assuming that since you're at PyOhio, you all have Python on your machines. I'm using Python 3.2 on mine, but as long as it's compatible with whatever Pygame you download, that's all that really counts. Okay, so who am I? You mentioned I teach computer science at Muskingum University, and as part of that effort, I've tried to introduce Python into some of the lower level classes, and we've had a lot of great success at that. And this tutorial is partly an outshoot of my experiences doing that. I also worked in industry for 15 years, and I saw a really lot of bad software design, and I wrote most of that bad software design. But as a process of doing that, I learned a lot about what makes for a bad design and what makes for a good design, and how you can have a design that will scale a little bit more gracefully than a bad design. Okay, so my background is not Python in the sense that I did not grow up learning Python like some of the very fortunate younger people here are going to be. But I love the language. My chances to use Python have been fairly limited to personal projects and teaching lower level classes. So my code might not always be Pythonic. And by all means, if you see a better way of doing what I'm showing you how to do, shout it out. Let me know how to do it, because this is a tutorial. It's for all of us to do together, not just for me to sit up here and type. Okay, so I want to get a sense of where you all are at, what you're bringing to this room. So in terms of Python experience, how many of you have been doing Python for more than 5 years? Okay, fairly small amount. How about more than 3 years? Okay, more than, how about less than a year? Less than a year. Okay, so we got a really nice mix. Like I say, we're focused more on architecture here, but we'll be trying to accomplish something and actually create a Python program using the model view controller architecture. How many of you work as a professional programmer? Okay, good. You'll get all my jokes. Some of the others might not. So a lot of this, as I said, comes from my experience in industry in not only writing really bad code, but having to maintain someone else's really bad code, which teaches you a lot about what you never ever want to do when you write code, because you had to suffer through maintaining their code. Okay, so some common development practices. These are the ways that typically you might go about developing a piece of software, a large piece of software. So all the code for a program goes into a single module because that makes it easy to get started. You have quick turnaround times. You don't have to manage the multiple modules. You might also focus on specific user functionality, doing just enough to get the feature working. And this is good for the users because they can see things quickly. It feels good for you because you get something up and running really quick. And then you write to support the specific application that you're writing. Because after all, if the user doesn't want it, why bother writing it? So this is kind of typically how software development is done. Some of the common results of this. Eventually, those pesky users ask for changes to your application because they're never happy with what you've written. Chances are, as soon as you give it to them, they say that, no, that's not what I really wanted. What I really wanted was this other thing. So significant changes to the code, in this case, usually require significant rewriting of the application. And the original design was so targeted that it can't really be reused gracefully for even a similar application. Seemingly minor changes can cascade throughout the code. You might have heard the term fragile code, where you poke it in one place and something over here bulges out and breaks. This is kind of the results of a common first try development effort. Or pictorially, you get spaghetti code and unhappy developers, because eventually the users come back and make it clear that the code that you wrote and were so proud of is not as robust as you had thought it was. So what is Model View Controller? It's a software design technique, so it's kind of a pattern of how to separate the modules in your program and what to put in each module. It's a way of organizing code. We have three basic modules, although view and controller are often combined, especially for smaller projects. It's a way of separating concerns. Spaghetti code is called spaghetti code because everything kind of interconnects. There's no clear separation between you do this and I do this, and when we need to talk, it's through a well-defined interface. There's no separation of concerns in the normal development model. So Model View Controller has this kind of built in. It's not the only way of having a separation of concerns, but it's the way that we're talking about right now. So the possible results of using Model View Controller. It's a little bit better. You can see that you've got two masses of spaghetti that are talking through well-defined interfaces, but the individual masses of spaghetti are still masses of spaghetti. Model View Controller alone is not enough to create a good, robust architecture. You also need some good design techniques, and we'll talk about that as we go along too. Okay, so my philosophy on software design that I have gotten through years of writing really bad code. Designing software ahead of time is important, but not all at once. I went through that stage where I wanted to design the entire program up front because I was confident that that would lead me to not writing really bad code. All that led me to was eventually not writing code at all because I never got through the design process. And projects were canceled because they were so far over time because we hadn't produced anything yet. Whereas if we'd been producing things all along, they wouldn't have minded so much that we were over time. So it was more the perception that we hadn't actually done anything yet. Iterative development is awesome. How many of you have heard the term iterative development? Okay, most of you. Basically, iterative development is where you do a small amount of code and you make certain it works before you move on. And so we'll talk about how that works with Model View Controller. But each iteration has to be properly designed. If all we do is focus on the user wants a button here, and when they click it, they want this sound to play, and we just throw some code together that does that without designing it, then we end up with the spaghetti code in the individual modules. So we want to take the time to design this right up front. It'll take a little bit more time up front, but it pays off big in the long run. Okay, so Model View Controller, we've got three different things, and each has a certain area of concern, a certain set of responsibilities that they have to do. So what is a model? It basically manages the data for whatever it is that your program does. So if you imagine a program that was just in the Amazon arbitrage one, imagine a program that scrapes data off of Amazon and stores it. That data is in the model. The model also manages operations on that data. So an operation that is solely about the data can go in the model. It provides a well-defined interface to the data. And this interface should be complete in the context of the problem domain. And what I mean by that is if you have, for example, a model that deals with a chess program, you want it to support everything that chess supports. Even if all you're writing is a simplified version of chess that doesn't support some of the more advanced features, you want your model to support everything that chess should support so that you can reuse it in other applications later. And it should not be specific to a particular application. So we got our chess model. We could write a full-featured chess program. We could write a chess program for beginners that tones down some of the more advanced features of chess. We could write a program that would allow us to replay famous chess matches by reading in the moves. And that model would work without change for all of those different applications. And that's what we're going for, is to be able to write code that can be reused in a lot of different ways without having to rewrite the code. Okay, so what is a view? A view is a way to visualize the data. This basically gives the user something to look at. Otherwise, they don't know that your program's doing anything. There has to be something on the screen that allows them to see what's going on inside the model. So a view could be a graphical user interface. It could be a scrolling text screen. It could really be anything that allows the user to sense what's going on. So it could be, if the program has to do with music, it could be the view that plays the music. And another view could show the notes. So for a given model, you can have multiple views on the data. And each view just focuses on how it needs to present the data. And then the controller is the part that handles user input. So it says when the user presses the space bar, this is the action that happens in the model. It maps that user action to a model action. And it might also map the user action to something in the view. For example, you press F1 and it switches to a different view. So this is basically how they communicate. That's not too bad. So the user, at the very bottom, interacts with the application through the controller. Depending on what they did, the controller either invokes some behavior on the model or it changes settings in the view. You know, if you've got a first-person shooter, maybe it's changing the depth of the view or the field of the view. And then the view, whenever it needs to, requests the state from the model and then visualizes the data in a way that is meaningful to the user so that they can use that to make decisions about what else they want to do with the controller. So this is the kind of the separation of the concerns and the way that they're supposed to communicate. If you do reading on MVC, you might see something about a more of an event model where the model pushes events down to the view. That's basically an efficiency concern. For the program that we're going to be writing today, it's the model, the data is entirely small enough that the view can fetch the entire thing whenever it needs to, and so we don't have to worry about that additional complexity. If you're doing anything that has communications latency, though, like you have a view that's across a network, you're having to pull data across the network, then you would want to look into having the model push just changes to the view so that you're not pulling all of the data across the network every single time. Okay, so where do we start when we're designing a program with model view controller? We start with the model. We need to figure out how to store the data and what operations we want to have on the data. And again, this is not in the context of the particular application that we're writing, but in the context of the problem domain, whether that's chess, whether that's checkers, or whatever. So the application that we're going to do is an application called SameGame. This is a really old game that was never really popular, and then people like Bejeweled put fancier graphics and more rules on it and made it a bestseller. So SameGame has been around for a long time. The basic rules here are that if you have, for example, these green blocks down here, there are green blocks touching each other. If you have any blocks of the same color touching each other and you click on them, all of the blocks that are touching the block that you clicked on that are of the same color are removed. If you click on a single color block that has nothing of its same color, nothing happens. So that's our goal, is to implement as much of this as we can. And we're going to be doing it iteratively so that after we do enough interesting operations on the model, we'll work on the view so that at least we've got something running even if we don't get through the entire thing. In the case that we don't get through the entire thing, up at speaker bar under this tutorial is all of the source code for working versions of it. In this example on the left, I clicked on the green blocks in the lower right, and they all went away, and everything dropped down. Nothing new came in the top because we're not Bejeweled. This is the original game where you just try and clear as much of the blocks as you can. The game continues until you have no more matches left. So we're sticking with the basics for simplicity because we're here about the architecture, not about the additional rules that we could add on to it. You could take this model very easily, add on more rules, and create more of a Bejeweled-like game. Okay. So what first? We have to start with the model. I also want to take a moment to mention this is a 2-hour block during which you'll be doing a lot of coding. If at any point you feel the need to take a break, please do. Go to the restroom, stretch your legs, whatever you need to do. Okay. So as part of the model design, here are the steps that I like to go through. One is to identify operations on the data. So conceptually, what operations do I need? Then I want to identify the data structures. Now that I know kind of what the operations are, how do I want to actually store these in a Python data structure? And then I want to implement one operation, and one operation only. Then I want to test that operation. Now, in a real model, sometimes you can't get by with testing just one operation because they interact. But we're going to do as close as we can to one operation. I test it, and we'll talk more about testing later. And then we repeat steps 3 and 4 until we're done. Now, in reality, we're not going to do the entire model like this before we start anything in the view, because that would be kind of boring. And we want to have something to show. So iterative development means we want something to show. So what this means is that as soon as we get enough interesting operations done in the model, we want to start implementing the views to support those operations. So what interesting means depends on your model, and we'll decide as we go along what interesting means for us. Okay, testing. I mentioned testing. How many people here have done unit testing before?
Done what?
Unit testing. Okay. A lot of you have, but probably not. Unless you got a really cool school. So unit testing is basically you write a function, and then you test that function, and you do it programmatically. You write code that calls the function with different inputs, and you identify all of the possible inputs. Ideally, you would exhaustively test all of the possible inputs to that function. Now, that isn't always possible, so we like to identify things called boundary cases, the places where we might break the code, because when you're testing, you want to try and break the code. You want to get out of the mind of the person who just wrote that code who wants it to work, and if you're the tester, you want it to fail, because then you've succeeded at your job. So in unit testing, we do this programmatically. Some of you have probably used PyUnit. Some of you have probably used PyTest. I don't use any of those because at the level that I'm teaching this at Muskingum, that's just added complexity that we don't need. So I'm going to do my unit testing here with a very, very simple method that I define one function, and then I just call that function to verify my tests. Yes?
This may be out of scope, but I was curious about your thoughts on unit testing like that versus test-driven development or test-first development.
Repeat the question.
Oh, sorry, yes. I have to repeat the question because I'm on a microphone. The question was my thoughts about unit testing versus test-driven development, essentially. I'm not really invested one way or the other in when the tests are written. I think tests have to be done, and my kind of natural method of development is to write some of the code that I'm testing before I write the tests. I see a lot of value in the other way of doing it too, if that is what works for you. Because really, until the code is written and the tests are done, you're not certain that anything works. And so if you write the tests first because you've identified what the functionality has to be and you've identified all the inputs that you want to test, and then you write the code, I'm fine with that. I see value in both ways. Okay, so let's identify the set of operations that we think we need in our model. This is the point where hopefully someone will take some notes. Let's see, I'll probably got something simple like Notepad on here too. So we have a block matching game. And we need to identify operations. What kind of operations do you think we need?
Calculate the field that you're going to select blocks from
What's that?
to populate your game grid.
Okay, so populate the game grid. And then I heard something else. Okay, so click. So in terms of the model, we want to stay away from user interface-ish kinds of terms because we don't know what kind of a view is going to be on here. Remove block. Yeah, that would be more of a model-oriented term. Because I might very well use this model as part of an artificial intelligence experiment where the AI is removing blocks, without a click. Yes?
Gravity first, remove a block underneath other blocks, and then they'll fall.
Okay. Yes, we absolutely need that functionality. And let me distinguish between public operations and private operations. So we need a set of an interface that the view can use to communicate with the model so that the view knows what it can ask the model to do. And the view is never going to say, okay, institute gravity. That's just part of the model. So that we'll have to deal with that, and that's going to be a significant piece of code that we write. But it's going to be private to the model. So there'll probably be a function inside the model that we don't expose to the view.
And color
For
for a block.
so get a block color.
You want to identify the block itself?
In
Properties?
what way?
The block being the model itself. So the existence of it and its properties of color, shape, form. Where's that?
Okay. Well, we have color as something we can get and populate. So we're looking at operations right now, and then we'll look at the data structures.
Okay.
So the operations will inform our choice of data structures and how we actually store everything.
Number of blocks?
Yeah. So the number of blocks, number of blocks left. That could be part of scoring, depending on how the view wants to do that.
You need to track the number of moves as well.
Number of moves.
Give position of blocks, their relation to each other.
Yeah.
Get the block above me.
I think.
Get connected blocks.
Yeah. Let's put that down private. I have gravity. Need to put gravity down here. So get related blocks. Now, the reason that I'm sticking that in private is because what the view cares about is removing a block. The view doesn't care about what needs to happen to remove a block. The model has to care about what is going to happen there. So just based on having done this project before, I'm kind of partitioning things a little bit. Any other? Mm-hmm.
So, if, say, it's a 10 by 10 grid, after you remove something in the middle of the entire column, you're going to have to shift the rest of it to the right/left, so that way they'll be connected again.
Okay, so you're suggesting that when we remove an entire column, we shift left or right? Which way?
Whenever an entire column gets moved, it gets shifted.
But which way?
How about it shifted, I don't know, doesn't really matter.
Well, I don't care. Oh, we have a suggestion for to the right. Okay. Okay, again, I'm going to stick that in private. Now, fair disclosure, my solution does not do that. I implemented a simpler version of the game. You can feel free to implement the simpler version if you want, or implement the version that does this. Basically, if the model supports it, the view doesn't care. Yes?
Are there possible moves remaining?
Possible moves remaining. That's a good one, because that is actually when the game ends, when there are no more moves remaining. We can count them. We can just say whether there are possible moves. I don't know that it particularly matters. I guess it would be most flexible to actually count them in case that matters to a particular view.
What level you're on?
Yeah, actually, the simple game that I wrote doesn't actually have levels. It's just got one level. But, yeah, we could do that, too. Okay. One thing we're missing is that the view has to... I'm sorry?
I was just suggesting
Score?
score.
Did we... Oh, I thought someone had suggested score. I must not have put that in. It could also be... Score is a little bit vague on whether that belongs in the model or the view. Because different views could certainly implement scoring differently based on the other statistics that we have. A view could do it based on the moves remaining and the number of moves that they've made, or they could just do it strictly on the number of blocks removed.
Or maybe like the time?
Yeah. So I think I'm talking myself more into that being a view-oriented thing.
So are these attributes of the controller, or are these just overall methods that we need to implement where we decide whether it's a controller method or if it's on the...
No, these are all model.
These are all model behaviors.
All model behaviors that we're trying to identify right now. Okay, so a view is going to have to display the model. How would you expect that to happen? What kind of a programming structure would you use to display a two-dimensional grid? That would be the data structure. So in a typical matrix, you might need to know the height and the width. So those might be model methods too. Now, again, we could get more Pythonic and we could expose more of the data structure. But one of the keys of MVC is insulating the views from any possible implementation changes so that, maybe we store the data as a two-dimensional list. And then later on, we're dealing with much larger grids, and we decide that we need to use, NumPy arrays. If we are exposing the actual data structure to the view, then the view has to change. But if all we're doing is exposing these operations, then the view can continue to work. So we want to try and hide the implementation details from the view. Okay, so this is a good set of operations. Not sure. Do I have anything left in... Okay, data structures. So we know we need to store the block color. And we can, getting the block color implies that we have to identify a block in some fashion. How would you identify a block in the grid?
Cartesian coordinate.
Yeah, we could do a row and column, X and Y. I always do row and column when I'm programming because in like two-dimensional data structures, the row comes first. But I always want to put X first, and that's the column, and it always flips things around when I draw it. So we need a row and column. So how might we store a two-dimensional data structure? Yeah.
Well, since we're going to be removing stuff from the middle, like listed lists,
Yeah. For efficiency, for removing things from the middle, list to list probably makes a lot of sense, yeah. Okay, so we have some public stuff, we have some private stuff. And we kind of have said that we're going to do a list of lists. Now, note that we haven't written any code yet, so all of this could change as we write code. We want to design the operations so that we have the full scope, but we don't want to spend a lot of time getting into the nitty-gritty of them because we might decide that we have to change them as we go along and we're doing some iterations. So design, but kind of lightly. Okay, so we're going to start implementing code. This is when the PowerPoint goes away, because this is a loaner laptop and is not fast enough to do very much at the same time. So I will start here. Okay. And I'm just going to get rid of all the boilerplate. Is that good? Okay. So we said we want a list of lists, and it has to be so big and so wide. I did my solution on a 10 by 10 grid, but one of the really nice things about this set of operations that we've identified is that the view can get the height and the width, so we can really easily write the view so it will support any sized grid.
100 by 100.
100 by 100. Okay, so I guess I'll call it data. So I'm going to start out with nothing in a spot. And got a square bracket missing. There, 100 by 100 grid. And actually, in my original solution to this, I actually wrote out all the nuns for a 10 by 10 grid, and then a couple days ago discovered this shortcut. So it's good to keep learning the Pythonic way of doing things. So we have to pick one operation to start with. Which operation should that be?
Randomized colors.
Randomized colors. Okay, how are we going to test that one? What would we have to do to test that?
grab a couple of blocks from the grid and make sure they have colors.
Okay, that they're not none,
Yeah.
and ideally that they're not the same, but randomly they might be the same. We could also visualize that through a view to run it a couple times and just kind of visually verify.
You iterate over all blocks and count how many colors you have and make sure that
That's true. Okay, let's do that. I like that. Okay, so we need to randomize. And I guess I don't really need anything there. All I need to do is to iterate over the grid and assign random numbers. So I have to import random. Has everyone used random before? Yeah? Okay.
Have to decide how many colors you have.
Oh, yes. I do need to decide how many colors I have. I don't know. If it's too big a number, there's not really any game because there are no adjacent colors that are the same. 5 seems to work pretty well for the sample that I'd written before. So I'll go with 5, but you can put whatever you want in there. I'm going to create myself a pseudo constant there and use that instead of a magic number. Okay, so I need to do a set of for loops here to go over the grid. Now, in terms of the for loops that the ways of going over a grid, everyone is familiar, hopefully, with the for I in range mechanism in Python, right? Okay, and everyone is familiar with the for I in list mechanism. Okay. Which one of those would we need to use here in order to set a value inside of the list? It would have to be nested. Okay. And you suggested the I in list? Okay. Let's do it. And I'm not going to actually use I because I like more meaningful. Oh, yes. Thank you. I need to start using that, the row column, or else I'll get myself all confused. Okay, so this is a... thank you. Yeah, unfortunately, in our classes, we switch back and forth between different languages, and
You got your data row switched around there.
thank you. Cool. Okay. And then I need to
Data sub row. Oh, wait.
Data, bracket row, bracket column, equals.
You're iterating over the data, so you're pulling out the values from the data structure. We want to assign to it, so we need integers, we need arrays.
correct. So in this case, the nice syntax for I in list doesn't work so well. I mean, we could try setting a column to a particular value and seeing if it's stuck. But the way that I would normally do it, and whether that's more Pythonic or not, I don't know. What am I wanting? Len, thank you.
Why don't you just try it the way it was, see if it works, column equals random.
He's iterating over the data. You can modify the...
Yeah, that's a big problem. You cannot modify the individual cells.
Yep.
It won't work.
Yeah, that's what I was saying. The choice of for loops is important here. So let me change this right now. As you can tell, typing is not my strong suit. There we go. And then change this.
No, Len,
Here you need
data
data
sub
sub
row.
row.
Thank you. Okay. Well, let's save this as model. Okay, so theoretically, we have a function that will work. Now, for unit testing, we want to programmatically test this. There's no way that we can test every possible outcome of this because it's random. That is one of the shortcomings of unit testing, is that it's difficult to test randomly generated data. There are ways of doing it. We can overwrite reassign the random.randint, so it's giving back a sequence of numbers that we know about and verifying then that the function at least is doing the right thing. But that's really more complicated than we want to get into. So I like the idea of just generating the grid and then counting the number of distinct colors. So what I'm going to do is open up a new module.
Wait a second. If that, go back to the other one. What was it? Yeah. If you have it do all that stuff in a function, don't you have to call it later, or what if you just put it in normally, since it only has to do it once anyways? Stuck it in there. And
We don't know necessarily that the view is going to want to randomize the data. There may be other options involved. So putting them as a function so that they can get called when they need to be called is fine.
also, I thought you had to put what was it? The different variables have to be placed in there as well. So if it calls for data, wouldn't you need to have it ask for that in little parentheses by randomize?
It can get to the data that's in the same module. Depending on whether we're trying to change the data or not, we have to define it as global. And we'll get an error message if we call randomize data, or randomize, and we have not defined it as global. Okay. So in this case, it would probably be safest to declare that as global. Okay, so let's do one of the unit tests. So we've got this other module over here. What we want to do with a unit test is we want to call the function, and then we want to look at the data that either is returned or is affected by the board, and then we want to programmatically say whether the test passed or failed. Randomize is a little bit of a tricky one in order to test automatically because it is random. But I'm going to define a function here called verify that takes a condition and an error. And we'll say if not condition, print error. So the idea here is that we're going to call this after every single test, just like you would call an assert statement, and if you've used asserts before. We're going to pass in a condition that should be true, and if it is not true, we want to display the error message. So let me go ahead and save this as model test. So I'm going to have to import in here the model so that I can get to the functions and the data inside the model. Then I can call
You do need parentheses around.
You did in Python 3.
around print I do, around the if I do not. Those darn Java habits. Okay. So after I call the randomize, I need to get to the board data that's inside the model module. And I'm just going to do that with model.data. But then I have to do something with that to verify whether it's correct or not. The suggestion was to count the number of distinct colors. And in a 100 by 100 grid, if we don't get 5 distinct colors, there's probably something wrong. I mean, it's possible because it's random, but the chances are slim. So we want to do this again. And this time, since we're not trying to change the data, we don't need to get the index. Let's see. What else would I need to count unique colors? Yeah. If I don't have that list, then I'm not going to be able to test it. So first thing I'm going to do is I want to check to see if the current color, which is in call, is in colors. And then not that, because I don't really care if it is. So if it is not in the colors list, I add it to the colors list and I bump up the number of colors. When I get done with this, actually, call the verify. And I should have that backed one more. So you call it verify by giving the condition that should be true, and then an error message that says what went wrong if it isn't true. And so this is the basics of how we're going to unit test the entire thing. We call the method, we validate that it either worked, and if it didn't work, we print out a message. Now at the end of the unit test file, I always like to print out something, because if everything works, no error messages get printed out and you're just looking at a blank screen. So it's satisfying to have something print out at the end saying that you're done.
You should also have it print out all the different colors at times.
To validate that they're in the right ranges?
Yeah.
Ah, let's see.
And you could put, what was it? What are those thingies? They look like little slanted tic-tac-toe boards. What are those?
Oh,
And you use them
the comments?
and you use them for comments. What you do is you can put those, and then you can put one of those symbols and put DBG for debug, so it's just a debugging statement.
Well, this is all unit testing. There's nothing production in this code. Okay, so this is the basics of the unit testing. Let's go ahead and run this and see what happens. Okay, it says all tests run, so it means that it got all 5 colors in there. If it had said if it said that the test failed, since it's a randomization of the board, I would have had to have run it a few more times just to make certain that it really was not working. As soon as we get all tests run and nothing was wrong with that particular function, we want to move on to the next, because we're trying to do some quick iterations to try and get through the entire game if we can, or at least have something to show. So what would be another operation that would make sense to do next? Remove block is a biggie.
Do we
Get block color, that would work. Because if we get block color and we get height and get width, then we can start visualizing things in a view. So we want to think about the subset of operations that we need to actually visualize something in a view so that we can get to that part of the code too. So let's do the get block color. So over in the model, so assuming that row and column are integers, what do I need to do in this particular function? How would I get the color of a particular block?
We're using X and Y coordinates, right?
Yes. I could do, that. So I won't see anything wrong with that. Not syntactically, but logically. I'm sorry?
Return that data from where?
It's a global variable. You can read the global variable without any trouble. Yes, it could throw an exception if the row and the column that I pass in are not valid. So this is another aspect of model view controller, is that the model has to take charge of its own error checking. It cannot rely on any particular view passing in good data. So it has to return something other than a program crash, unless you have some sort of an exception handling mechanism set up, and we're not going to get into that. So what I want to do here is that if the row is less than 0, or the row is greater than greater than or equal on data, or call is less than 0, call is greater than or equal to data row. So basically just checking the bounds of everything.
Does call need to be greater than or equal to? It's the same as greater than.
Should be greater than or equal to. Because
Column is equal to.
if it's equal to, that's a mistake. Because the indices go from 0 to the length minus 1. So if it's equal to the length, that's an invalid index. And I almost invariably get these kinds of comparisons wrong the first time. So if it crashes, then when you test it, that's why you're testing. So if it's invalid, we would just return none as a signal that you did something wrong. Or there's, none might be a valid answer if there's nothing in that spot. So we've done get block color. We need to test it. So again, we go over to the test module. And we want to do the test get block color. Now we can't test get block color if we have randomized the board, because then we don't know what it's supposed to return. So instead, what we can do is we can just set data to some particular values. And see, I need going to do a simple 2 by 2 with unique values. So if I call getBlockColor with a particular row and index and it does not return me the correct value, I'll know that that function has failed. And again, this is a case where just testing to make certain it works is not enough. I have to test to make certain that the failure conditions are correct as well. So I test. Oops.
Model data.
Now, ideally, we would test every single square of this 2x2 grid and each of the error conditions together and singly. So just testing 2, 2 as an error condition for both doesn't tell me if each of the error conditions individually are working. It only tells me that one of them is working. So I would want to test a 2, 2. I would want to test a 0, 2. I'd want to test a 2, 0. I'd want to do a 0, 0, 0, 1, 1, 0, 1, 1. I would want to do all of those. We're not going to take the time necessarily to do that here because we want to get through as much of the iterations as possible. But yes?
Can we fix that? Because the 1 and the 2, there's a space in between them. But 3 and 4 doesn't have space.
Python does not care. But if it's bothering you, then we can fix it.
OCD does care.
So let me run this and see if I messed up the comparisons. Oh, okay. Under the principle of least work, I will change the parameter name. Oh. There we go. Okay. So at least those two tests worked. Now, like I say, that doesn't necessarily exhaustively test it, but at least shows that it's working in at least one of the error cases and one of the good cases. The version up on speaker bar has much more exhaustive tests that you can look at. So we would want to go then and implement another one of the methods. And we were trying to get to the point where we could have something for the view to show. So I'm suggesting that we could do get height and get width. So get height is easy. If I can spell it, it's easy. Because that's just the number of rows that is in data. Get width is a little bit more problematic. Because in a generic two-dimensional list in Python, the individual rows do not have to be the same length. So if I was being absolutely correct about this, I would pass the row in to get width, so that I was getting the width of a particular row. In this case, though, the model is guaranteeing that I have a square grid to work with. That's part of the problem domain. So I can safely just assume that I am getting the width of row 0 and return that. Okay, so now we need to test this. So we have to go over to the test module. And again, we're going to use the trick of setting the board data to specific lists so that we know whether the get height and get width worked or not. And in this case, I don't want it to be a 2 by 2, because if it's a 2 by 2, I don't know that it's distinguishing between height and width. So I want to add on something here. Oh, OCD alert. There we go. So that I have a 2 by 3 grid. Now I know that the get height is supposed to return 2. And get width is supposed to return 3. And then we run that, and it said all tests run. So now in this case, there really should be no error conditions because the model is guaranteeing that there will be a grid that has a positive width and a positive height. It's not really possible for that to come back as anything but a 1 or more.
What if you made it a 4-dimensional grid?
Then our model would change. The operations on the model would change. Okay. So we finally have enough to actually do some visualization because we can get the height, we can get the width, we can get the block color, and we can randomly populate the grid. So we have enough in the model to write some of the view code.
Let's do the get number of blocks black.
Well, let's do the view first,
Okay.
so that we can visualize something. Because we could keep writing model code and testing it, but until we can actually see something. So up on speaker bar, there is a kind of a skeleton of a Pygame view that has this stuff in it. Just to get some of the boilerplate out of the way. If you've never done Pygame before, you want to go up there, pull down this file. It's speakerbar.com/talk/8. We'll get you there. So basically, to use Pygame, you import Pygame and then pygame.locals. You have to call pygame.init. I've set up some color constants here just for us to use, assuming that we're going to have a black background and 5 colors, white, red, green, blue, and yellow. And then I've set up a tuple here with the particular colors. And I've made some assumptions on the width and the height of the individual pieces. And then the piece margin is the amount of black that we want between the pieces in the grid.
URL, real fast again.
Yep. /talk/8. Yeah, speaker spkrbar.com. And then we create a surface, which is basically a window. We fill it with black. We call pygame.display.update. And in between filling the surface with black and calling display.update, if we were to actually draw anything on it, it would show up. So that's where our code to pull from the model and draw it is going to go. And then if we try and quit, it quits. So right now this does nothing more than display a black window and allows us to exit out of it. So that's the skeleton that we're going to start with. So what we need to do here there's two things that we need to focus on. Here in pygame.display.set mode, we set the width and the height of the window. We want that to depend on the width and the height of our model grid. So each cell in the model is a single square in our view, and it should be, according to these, 30 pixels wide and 30 pixels high. So I have to take the number of, for the height, the number of rows, multiply it by the piece width plus the piece height, plus the piece margin, and possibly add in another piece margin. This is another one of those things that I always get wrong the first time. So oh, and I need to import the model in here too. Otherwise, I'm never going to be able to get to the data. Okay, so model.get height times the piece height plus piece margin. And then similarly for the width, this is almost certainly not correct, but it gives us something to run and at least see what happens. Right off the bat with the 30 by 30, 100 by 100 grid is going to make this way bigger than we can actually see. So if we want to stick with the 100 by 100, we're going to scale down the piece width and height. And as long as everything in the view uses those two variables, we can just change it in the code and it'll automatically update. Okay, so let me go ahead and run this. So we can see that it's quite a large grid now.
It's at least 30,000 pixels wide.
That's going to be a little bit too big. So let's...
How about each piece 5 pixels wide?
let's see what this does. Okay, yeah, we can probably go up to... Okay, so we're going to have 5 pixels wide pieces. Now down here, between the window surface.filled black and the pygame.display.update, we need to draw each of the squares that is part of the model. So we're going to call that get block color as we go for each of the squares, and then draw an appropriately colored rectangle. So we need to do a for so for row in range model.getHeight, no matter what the model height is, it'll take on 0 to that height minus 1. And then same thing with get width. And we get the color. So we're using those operations that we defined on the model in order to interact with it. We're not going just straight into the data structure. Now we need to draw the rectangle. And I always have to look up the Pygame syntax. There it is. So I want to do a pygame.draw.rect. And I pass in the window surface that I created for my window. Then I have to pass in the x and y coordinates. Now this is where it switches to x and y. Pygame uses x and y. In the model, we're using row and column. So column is the x coordinates. Row is the y coordinates. So we're going to switch from using row first and then column to using column and then row. If you don't, it'll still work, but your pieces will fall to the right instead of falling down.
That sounds awesome.
Then you can do it like that.
What if you gave anti-gravity? Everything falls up.
That would be another separate... Okay, so we have to give it the color, then we give it a tuple with the coordinates, and okay, so we take the column times the piece width plus the piece margin in order to get the coordinate, and then we'll go with that for now and fix it as it looks like it's not working.
I think you'll need the piece margin plus, and then after you get that, you're going to need to add the piece margin again. So you're going to need column times piece width plus piece margin plus an extra piece margin at the end.
Okay.
Say there are 5 pieces, there are going to be 6 piece margins. But the extra piece margin is going to need to be outside the.
Okay. Now, there's still a bug with this in that I have passed in to pygame.draw.rect the color that I got back from model.getBlockColor, which is an integer. That is not a valid Pygame color. But in the piece colors tuple, I set up the color so I can just index into that tuple with the number that I get back. Okay. So theoretically, this will display something, unless it crashes on me.
I think you accidentally put Pygame instead of Pygame.
That is entirely possible. Yep. Okay. Not the crash I was expecting. Oh, we still got some invalid syntax. I think I probably got parentheses off. Okay, rather than...
Oh, there are spaces. No, those aren't spaces.
Yep. I'm going to basically get this from the solution and copy it over, because we don't need to spend our time debugging my parentheses. Okay. Added in there from the solution is an if piece is not none, because presumably after we remove a piece, some of the squares will be none, and those should not be drawn at all.
Do you get to pick which color none can
Yes, you do that by what you fill the window surface with. So whatever you fill it with initially, that's the color that the missing blocks will be.
I was thinking I would have a color randomizer, so it picks through all of the different hexadecimal colors, and it basically just looks like a giant rainbow.
That would be cool. Let's get rid of that. Okay. So does anyone have a guess as to why it turned up all black?
Because of an error.
No. Well, an error, a person behind the keyboard error.
You didn't code it right.
Oh, it's coded fine. It's doing exactly what I asked it to.
You need to do some sort of like refresh to update the window.
What I neglected to do was ask the model to actually randomize itself. There's an implied contract with the model. It will do what I ask it to. There we go. There's our 100 by 100. It looks suspiciously regular. So something is wrong here. Unit testing only goes so far, especially with random numbers. There is definitely something wrong here. It suspiciously looks like it's using the same color for every column.
Luckily,
Yes.
that works great for OCD.
You only randomize the column, but you didn't randomize the rows.
Let's take a look into the model and see what's going on there. Model. Does anyone else see what is wrong with that? Because that actually looks pretty good. We're also using get block color. Row column, but that looks like that's returning the correct value too. Okay. In the philosophy of not spending too much time debugging right now, let's see what the solution does. Forward row column. That looks the same to me.
That one says non-colors -1, and then going to the other one.
Yeah, that's just changing the range of numbers that are generated. I would expect to see, with a column-oriented issue like that the column wasn't, or maybe the row wasn't changing, or so it looks very much like we're getting the last color picked in every single row in a column.
In get block color, it looks like the rows and the columns are backwards. The row should be len data sub row. Or column, I think. Because right now it's checking for the number of columns instead of rows there. I don't know if that matters.
Which one? This one?
Well, if you're making sure that the number of rows are
No. I'm not seeing how that's backwards.
Oh, no, it isn't backwards.
Problem may not be in your model, maybe in your view.
Yeah, I mean, the model is looking pretty good.
Print out data.
Well, there is a... No, that's row column. That's okay. Okay. I am not seeing the problem. So let me just do a sanity check. Okay, so the solution is now doing the exact same thing. And it had worked at one point. So there may be something odd going on that is specific to my machine. Has anyone else downloaded the solution?
I'm getting it too.
You're getting it too? Really?
I don't have my computer desktop.
Oh, you know the thing that I had changed fairly recently in the model is that syntax. I wonder if we're getting a reference problem where it's basically the same row reference. Okay. So apparently that syntax does not work well for what we're trying to do. So we're going to back off from the 100 by 100 because I'm not typing out that many. And I could do this programmatically. Yeah, why don't we do that? So is everyone familiar with Python references? Yeah. Okay, so the reason that we're getting this problem is that basically every row of this grid is the same row because of the way that it was created. So it has nothing to do with the randomize, with the get color. It has to do with how we're creating the grid itself. So in this, I'm going to whoa. We'll do that, and then in randomize, we'll create it. And there I go with those. Let's see. So here I want to create okay, so I'm creating the grid individually, element by element, so that I can guarantee that none of the references are the same. Assuming that works, which we can find that out. Okay, yep, that's much better. So every row is not the same now.
Cool. No, let's see, is there anything sort of...
I'll make it a time by 1,000.
Yeah.
You can do that with your own version. Okay.
Or maybe each one thing, and then you can have even more.
Remember, you got to click on these things eventually. Okay. So let's bring this back to the model. We have visualized a particular set of operations in the model. We need to, we could, at this point, also implement a different view. We could implement a text-based view that printed the grid out as letters for the different colors. Up on the speaker bar website, there's a version that does that. We could continue implementing the model operations, which is probably more interesting for us. The remove block is the most complicated of them, but now that we have a view that can actually see the contents of the grid, we can see the results of that.
Making testing easier?
Well, the testing should still go through unit testing, but if we can actually see it, that also helps too, because there's nothing, unit testing is not a replacement for user testing as well. So you have to do both. 30 minutes? Okay. Let's see if we can get the remove block done in 30 minutes. So let me take a quick poll. How many people are following along and implementing this as they go? A few. Okay. So how many people would like to have me implement this versus going through the solution that's up on speaker bar and talking about it? What would you get the most out of? Because this is, for you guys to learn this stuff.
Probably walking through the solution would be more useful than just now.
Okay.
Like, basically doing a line by line, writing it.
Okay. So let's look at the, if you go up to speaker bar and pull down the same game model. This is basically all of the operations that we looked at, but with comments. And there's a remove item where I pass in a column. The first thing to do is to check to see if it has adjacent items or not. If it doesn't, we're done, because we don't do anything if there's no adjacent items. So I've got this private method, or private function down here, has adjacent items, that basically just checks every single square, including the square that you clicked on. Because if there's nothing in the square that you clicked on, you're also done. So if the square that you clicked on is none, then you return false, saying there's nothing more to do here. If you have a color, then you have to start a kind of annoying checking of the square above it, square to the left, square bottom, square right. It's annoying because you also have to take account of those situations when one of those is off the board. And that's what these bounds checking are doing. So if they're checking the row above it, you have to check to make certain that the row is above 0. Otherwise, there's nothing above it. If you're checking to the left, you have to make certain the column is above 0. Otherwise, there's nothing to the left of it. And then similarly, for right and left, you have to make certain that you are not in that rightmost column, right and bottom, or that bottommost column. So, there's nothing particularly tricky here. It's just something that and I always like to hide this in a function so that I only have to do it once and I don't have to mess with it ever again. So that's what has adjacent items does. Okay. Now there are a bunch of different ways to remove items. I teach this part of a intro course, like a CS1 level course. And so I don't go with what would be probably a more natural approach, which would be recursion, because they haven't seen recursion yet. So instead, I do an iterative approach. The basic approach is I mark the item that I clicked on as I'm going to remove this item. And then I take a cycle through all the squares in the grid, And if any of them are next to an item that's marked for removal and they're the same color, then I mark that one for removal. And then I do it again and again until I get to a pass where I haven't marked anything new for removal. And that tells me that I've gotten everything. Because it's a surprisingly difficult task to have this chain, snaky chain of like-colored squares and find them all. So I've opted for kind of a brute force approach, knowing that these grids are not going to be all that large, at least not on my machine. And it seems to work pretty well. So that's the general approach. So I've got this temp board, which is basically a series of marks. So it's a copy of the overall board with a true if the item is going to be removed and a false if it's not. And then I initially mark the item that has been clicked on to be removed. And I've got a flag that says that I've removed something. And I'm going to keep going through a loop as long as I've removed something. First thing to do is say that I haven't removed anything yet this time around. And then I go through the double for loop, and I do that check. If I haven't already marked it for removal, and it's the same color as the one that was marked for removal, I mark it for removal. And I say that I've marked something this time. So like I say, it's a brute force approach, but it's fairly straightforward. And in this context, this particular application of grid processing, I didn't need anything that was too efficient. Then I go through and I actually remove them. Now I don't do gravity yet. All I'm doing is I'm marking them as none, saying that they've been removed. So I do that as one step. Then comes through gravity. And I do the same kind of thing. I say whether I have moved something or not, and I keep this loop going as long as I've moved something. And if there is any empty spot with an item above it, I copy that spot down one. And I keep doing that until the entire thing has been processed. Since the view updates are not happening during this process, we don't see the things go down. The view only sees the final result. Again, very brute force, but also very straightforward, and it works really well for the intended audience that I'm teaching it toward. Okay. In there I said item above and next to true. Those are a couple more private-ish functions. I say private-ish since I can't actually make them private, but I can not have them be part of what the view is supposed to use. Okay, so that's the removing an item. In the view, the solution view, I call the matches left on the model in order to see if the game has to continue or not. And then for block removal, we take a look at the mouse button, and if it's been clicked, we have to convert the X and Y coordinates into row and column for the grid. And this involves more of that funky math with piece width and piece margin. And it's really, really easy to get wrong, and I usually spend days just debugging this kind of stuff when I'm doing it. But that's what I ended up with, and it worked really well. I used the integer division because I didn't care if I was halfway into a piece or not. I just cared about the row and the column. Okay, so this is the kind of the process that I go through when I'm doing model view controller sorts of programs. The benefit here is that one of the benefits is that I can have multiple views on the same model. And so here's a text view that works off of the exact same model. So this prints it out in a grid of letters and allows me to enter a row and a column, and then it will display. Oh, it's still using the bad model. So, but it will display the exact same information, but in a textual view. I could implement a view that allowed a network player to play this. I could implement a view that just displayed statistics over 1,000 games that an AI played. So by separating out the model, the data in the operations, versus you can reuse the model in a lot of different ways. So that's basically it. Any questions? Yes?
What components would really constitute the controller of this? Consider you being the Pygame and your data 2D arrays being your model.
Yeah. Yeah. In this one, separate out the controller. Oh, I'm sorry. Repeat the question. What was the question was, what was the controller in this particular example? And I didn't separate out the controller into a separate module, but it was embedded into the Pygame where it had, for example, the if the button was pressed, that's controller code. It takes the user input into an action on the model. So in a simple program, you often do combine the view and the controller because it doesn't really make sense to separate them out that much. In a more complex program where I had a user interface that had like 3 different views that were displaying different aspects of the model, yes, I would separate out the controller because it would be operating on the model separately of the views. So you'll often see it just as the view and the controller together. Any other questions that I will remember to repeat this time? Yes?
Is there an example somewhere you have that has the controller separate?
The question is there an example that I have that has the controller separate? I do not have an example like that. Pretty much all the examples that I do are simple teaching examples, so I don't specifically have one now. Other questions? Yes?
Have you worked with Django, where it's the model template view? And
Yeah.
When you do, are you applying the exact same paradigm?
Yeah, I mean, they'd use different names, but the question. Have I worked with Django where they use the model template view as opposed to model view controller? Yeah, it's basically the same concepts, and it's a little bit different separation of concerns, but the important bit is that you're still separating out the model, and then you're having operations on that model. Other questions? Okay, well, thank you very much.